Hi, this is Ms. Warnow. Welcome back to Chemical Reactions. Today we're going to talk about types of reactions. We're going to basically start with learning 5 of these, but there are more that we'll add throughout the unit. So we're going to talk about synthesis, decomposition, single replacement, or we could call it single displacement, double replacement, or we could call it double displacement, and combustion. So the first one is synthesis, or combination. It's a combination of 2 or more substances. That would be substances on the reactant side that form only one product. So you can recognize a synthesis reaction because you only have one product. So if you took copper, reacted with solid copper, reacted with oxygen, you're going to get copper 2 oxide. That would be a synthesis because you only have one product over here. A decomposition is when a compound breaks down into 2 or more simpler substances. So you can recognize this because there's only one reactant. Okay, so if we look at the example, you have water that decomposes or breaks down into hydrogen and oxygen. So we only have one reactant there. That makes it a decomposition. A single replacement occurs when you have a single element reacts with an ionic compound and switches places with one of the elements in the compound. All right, so you can normally recognize this by you have an element in the compound and it gives you an element in the compound. And these are just letters representing the different, whether it's a compound or element. So you have element in the compound gives you an element in the compound. So you could have a cation displacement, so that you can recognize that because this is a metal, it forms a cation. It's going to replace the copper, and so you still get an element and you still get a compound. An anion displacement is when you have an anion here and it's going to displace the anion. You still end up with a compound and an element. And so I have here, let's kind of review balancing real quick. So you have chlorine. You have chlorine, potassium, and bromine. You have 2 chlorines on the left, 1 chlorine on the right, 1 potassium on the left, 1 on the right, 1 bromine on the left, and 2 on the right. And so what we can do to balance this is we put a 2 here. We'll get 2, 2, and then if we put a 2 in front of potassium chloride, we'll get 2 and 2. Ends up being balanced. Okay. And notice right here, why did this not have a 2, but this had a 2? Because chlorine and bromine are diatomic elements, and this actually should have been an L. It's a liquid there. All right, double replacement, ions in 2 compounds change partners. Okay, so you have a cation of one compound combines with the anion of another. So you will see a compound and a compound, and it gives you a compound and a compound. Okay, so this A and C switches places. Okay, you can think of it as cation switching, but you can also think of it as the anion switching. So a note here, there's a particular type of double replacement that you're expected to know. It's called acid-base, or you'll hear it called neutralization. It's a special type of double replacement. It occurs when an acid, you should recognize an acid because it starts with the hydrogen. The exception to that is water. And then you can recognize a base because it has hydroxide in it, OH. The exception to that we wanted you to know was ammonia, NH3. And it forms an ionic compound of salt and water. So you have an acid reacting with the base. You know, it's an acid because of hydrogen, a base because of the OH. And you get a type of salt. It doesn't have to be sodium chloride. A salt is an ionic compound, and then water. And water, notice, is in its liquid state. Move this up a little bit, and then here you have an acid you recognize because of the hydrogen. With the base you recognize because of the OH, and you're getting water. Notice that water is in its liquid state when it forms from an acid-base neutralization reaction. And then you have a salt here because it's an ionic compound. You know it's ionic because of that metal. And then we have combustion reactions. These are rapidly occurring reactions with oxygen involving light and heat. Commonly occurs when oxygen reacts with a hydrocarbon. to produce water and carbon dioxide. And a hydrocarbon is a compound that contains carbon, hydrogen, and sometimes it will have oxygen. So when we look at this, you have a hydrocarbon here because of the hydrogen in the carbon reacting with the oxygen, and the product is carbon dioxide and water for us. And notice water in this case has a gaseous state. It's not liquid because the amount of heat it takes when this is burning would vaporize the water and make it into a gaseous state. However, it does not just happen with hydrocarbons. For example, when we heat metal, magnesium in the presence of oxygen, it combusts. So this is actually a combustion as well. But you want to be careful. Just because you CO2 does not make it a combustion. And so for the scope of our particular class, we will classify combustion as reacting with a hydrocarbon with the products of carbon dioxide and water. So identify the types of reactions. So we're looking here. We have hydrogen, chlorine, and we only have one product. So we'll call this synthesis. We look at this. We have an element in a compound, and we get a compound in an element. So that makes that single replacement. This one we have a compound, and we're getting a compound and a compound. So we're going to say this is double replacement. Okay, write that out. This you have one reactant that breaks down into other substances, so that's going to be decomposition. And this one we have a hydrocarbon and oxygen, and our products are carbon dioxide and water, so that's going to be combustion. So you have to be able to memorize these types of reactions, okay? Now I have up here, let's review the little balance in here, so let me just extend this. All right, so we have one. So we look at this, we have carbon, hydrogen, and oxygen. So we have 3 carbon on this side, 1 on the right. On the left, we have 7, and then we have that one additional hydrogen, so that's going to kind of throw off our little tricky combustion rule from earlier. So we'll see how that affects it. And then for oxygen, we have 1 here and 2 there. There's 3, and then over here we have 2 and 1. 3. All right, so we can start by trying to balance the carbon. So I put a 3 here. I didn't start with the hydrogen because there's an even number of hydrogen right here with that 7 and that 1 here. Because that hydrogen sitting there, it kind of throws off that little tricky rule that I was showing you earlier. It's not really a rule. I mean, the only rule is that you can only change coefficients. So we have 3 carbon, and then we have 6, 7 oxygen. And so when we come over here and try to balance the hydrogen, so we have 8, so we put a 4 here. That makes that have 8, and then there's 6 plus 4 is 10. So now when we look at it and we say, oh, okay, we're going to try to balance this. If we put a 5 here, that's 10, but remember we have that oxygen setting over there. So that throws that off. So the little thing that I like to do is when I can't balance the oxygen, I've done everything that I can, I just go through and double all of my coefficients except for oxygen, and I recount. So that's what I'm going to do here. I'm going to change this to a 6, and I'm going to change this to 8, and I'm going to recount. Okay? I'm going to change colors to show I'm recounting. So I still have 3 on this side, still have 8, and I still have 3. On this side, I have 6 carbons. I have 12 plus 8 is 20 oxygen, and then I have 16 hydrogen. So I come over here, what could I put in front of this? A 2, so that makes me have 6, and I have 14, 15, 16 hydrogen, 14 here, and then add the ones there. And for oxygen, I have 2 plus the 2 is 4. but I need 20. So what could I put in front of here? So I need 20. I've already used up 2 right here. So subtract that 2. I have 18. So what number could I put here? It's a 9, and it makes it be 18. Like I said, combustions are pretty tricky, so you may want to practice with several of them. You also need to write equations from word equations, reactions from word equations. So what you need to be able to do is review, be able to write a formula, be able to say what the physical states of elements are at STP. So let's go over that. Most metals are solids at STP. The exception is mercury. It's a liquid at STP. The noble gases are gases. Most of the diatomic elements are gases as well, but there are some notable exceptions. Bromine is a liquid at room temperature, and iodine is a solid. And sulfur and phosphorus are solids as well. You need to be able to indicate those physical states. You need to be able to balance and make sure you remember your diatomic elements, because this is the unit that really comes into play here. All right, so a few things we will assume unless indicated otherwise is that the reactions are at STP, that water is a liquid except in combustion, and then acids are always an aqueous solution, so I don't have to tell you that's an aqueous. If I say it's an acid, assume it's aqueous. All right, so we have solid sodium, so we'll write sodium, it's a solid. Metal reacts with, that's plus water, H2O, and it's going to be a liquid because we said assume it's liquid. To produce is the arrow. Aqueous sodium hydroxide, so sodium hydroxide. Aqueous is AQ. And hydrogen gas. Hydrogen is a diatomic element. It's by itself. You need to put the 2 and then indicate it's a gas. And then we need to make sure we balance this. So we have sodium, hydrogen, oxygen. We have 1, 1, 2, 3, and then 1 and 1. So what will we need to do to balance this? So we could put a 2 here. If we put a 2 here, that makes us have 4 hydrogens and 2 oxygens. Okay, so over here, if we put a 2 here, that makes us have 2 sodiums, 2 oxygens, and then 2 hydrogens plus 2 hydrogens are 4. And then last thing we need to do is put a 2 right here, make us have 2 sodiums. This is what you have to be able to do. This ties in your nomenclature unit, your balancing unit, as well as the current unit. Okay, one more. 1 molar of lithium hydroxide. That 1 molar indicates that lithium hydroxide is an aqueous solution with 2 molars of phosphoric acid. So this acid, it's an acid, so you know you have hydrogen. It doesn't have hydro, so we're thinking of a polyatomic ion. The it goes with 8, so it's phosphate, PO4. And phosphate has a charge of -3, so it takes 3 hydrogens to balance. Since it's an acid, we know it's going to be aqueous. And it reacts to produce a solution of lithium phosphate. Notice I'm writing the proper chemical formula. Lithium has a +1 charge. Phosphate has a -3. It would take 3 lithiums to balance the phosphate. It says a solution, so it's AQ. And water, H2O. And we assume it's a liquid unless otherwise stated. And then we have to balance this, so we'll go with lithium. And I'll show you a little trick when you have hydroxide and hydrogen, you have water on this other side. If you think of it as lithium as H and OH, I'm going to show you that. You don't have to use that method, but I'm just going to share little things I do. So you have 1 lithium on the left, 3 on the right, 1 hydroxide on the left, 1 on the right, 3 hydrogen on the left, 1 on the right, and 1 phosphate, 1 phosphate. So we need to get 3 hydrogens over here. So if we put a 3 here, remember, I'm viewing this water as HOH, so that's 3 hydrogens and 3 hydroxides. And so what would we need to put over here is a 3, so we get 3 lithiums and 3 hydroxides. Balance. You can separate the OH and make it like, it's fine. It's just, I'm just sharing you things that I do. This concludes video 2 on reactions. You should have taken high quality and in-depth notes. Rewatch the videos as needed and ask questions.